If S1, S2 and S3 represent the sums of first n natural numbers, their squares and their cubes respectively, then verify that 9 times S2 squared equals S3 times 1 plus 8S1. Okay, let us begin. So here in the problem, it is given that S1, that is the sum of the first n natural number, because it's represented by summation of k, where k runs from 1 to n. If we expand this is simply 1 plus 2 plus 3 all the way up to n. And we know there's a standard formula for representing the sum of the first n natural numbers. That's given by n times n plus 1 divided by 2. So this is S1. Next we have S2. The S2 is summation of k squared with k running from 1 to n. So when we expand the summation, we get 1 squared plus 2 squared plus 3 squared all the way up to n squared. Now what is this? This is the sum of the squares of the first n natural number, and we have a standard formula for representing this sum. That's given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6. Then we have S3. So S3 is summation of k3, where k runs from 1 to n, and this is simply 1 cube plus 2 cube plus 3 cube all the way up to the last term, which is n cube. So this is the sum of the cubes of the first n natural numbers, and we have a standard formula for this one as well. So we have n squared times n plus 1 whole squared divided by 4. We're going to use this. So let's start from the left hand side of the expression, which is given by 9 times s2 squared, which means we have 9 multiplied to s2, squaring s2. So we have to square this sum. So that gives us 9 n squared times n plus 1 whole squared multiplied to 2n plus 1 whole squared divided by, so squarings give, this was 36. After simplification, we get 1/4 of n squared times n plus 1 whole squared multiplied to 2n plus 1 whole squared. Okay, now let's come to the right hand side, where we have s3 times 1 plus 8s1. So on the right hand side, we have s3 multiplied to 1 plus 8 multiplied to s1. This is going to be equals to, so we have n squared times n plus 1 whole squared divided by 4. So this is going to get multiplied to 1 plus 8 times, we have n times n plus 1 divided by 2. So we're going to get n squared multiplied to n plus 1 whole squared divided by 4 multiplied to 1 plus, so 2 times 4, that's 8. So we have 4 times n multiplied to n plus 1. Let's further simplify. We have n squared times n plus 1 whole squared divided by 4 multiplied to, now we have 1 plus 4n squared plus 4n. Now 1 plus 4n squared plus 4n, this is simply the expansion of 2n plus 1 whole squared. That means we now have n squared multiplied to n plus 1 whole squared multiplied to 2n plus 1 whole squared divided by 4. Let's compare it with the left hand side. So this is exactly what we are getting. So this proves that n s2 squared equals s3 times 1 plus 8s1, where s1, s2 and s3 represents the sum of first n natural numbers, their squares and their cubes respectively.